Welcome back. Now we're going to do some examples with rational expressions that have monomials in their numerators and their denominators. So adding and subtracting, with adding and subtracting, you need to have the same denominator. So what I'm going to do to start off is I am going to break down the denominator. So my first fraction is 6 times b. You don't have to do all of this, but I'm going to show you what it's going to look like in factored form. So writing out the prime factorization. So 6 is 2 times 3, and then we have b. So 2 times 3 times b. Plus, in this denominator, we have 14, which is 2 times 7, and then a squared, which means a times a, and b squared, which is b times b. All right, numerators. I'm just going to go ahead and leave those alone. And remember, when we add and when we subtract with fractions, we need to have common denominators, which means that their factors have to be the same. Their denominators have to have the same factors. So we need to make the denominators match. And if they don't match, we multiply the other fraction by whatever it's missing, and we multiply that on top and bottom. So notice that these two fractions, their denominators, both have a 2 in the denominator. But this fraction over here has a 3 and this one doesn't. So I'm going to have to multiply this fraction by 3 in the denominator. And if I'm going to put it into the denominator and it wasn't already there, I'm going to also have to multiply by that in the numerator. This fraction on the right has a 7, but the one over here on the left does not. The fraction on the right has a times a, but the fraction on the left does not. So we need to multiply by a times a, or to simplify that, we can write that as a squared. The fraction on the right has 2 b's in the denominator. The fraction on the left only has 1 b. We need to make them be the same. So that means we need to make them both have b times b. So that means the fraction on the left needs to also get multiplied by another b. So if we're multiplying by all of this in the denominator, we also have to multiply by it in the numerator. So in the numerator, we're multiplying by 7, and then a squared and b. All right, so we are going to go ahead and write our denominator using our LCD, our least common denominator, which is 7 times 2 times 3. So let's do 2 times 3 first, which is 6 times 7, so that's going to be 42. And then a squared, and then b squared. Plus, same denominator over here because I already made it, so they'll match. So 42, a squared, b squared. And then the numerator. Now we'll have to multiply. So 7 times 5 would give me 35. A squared times a squared would be a to the 4th. Using that product rule, keep the same base, add their exponents. And then b, we can't combine that with anything, so we'll just attach it at the end. So that's going to give me 35 a to the 4th b. Plus, over here, we're just taking 9 times 3 because 3 was the only factor missing in this denominator. So that's going to give me 27. And then the final step, possibly the final step, is going to be write this as a single fraction. So the denominator stays the same, 42 a squared b squared, and the numerator we add. So this is an unlike term because this is a to the 4th b, and like terms have to have the exact same variables with the exact same exponents. So the best that I can do is just write this as 35 a to the 4th b, and then plus 27. All right, so now that I have it written as a single fraction, I'm going to try into the numerator, I'm going to try to factor, see if anything can factor. So 35 and 27, are they both divisible by anything? And they do not have any common factors. This had a to the 4th b. This doesn't have any variables, so I can't factor out a GCF. It has 2 terms, so I try to do one of my formulas for 2 terms, but it doesn't match any of my formulas, which means this right here, all of this would be my final answer. Let's do another example. Again, this has monomials and one polynomial, and that is up in the numerator. But right now, my fractions, okay, I can rewrite all of these as fractions by taking my integer values and putting them over 1. What I need to do is I need to break down my denominators. So this is 1, this is 1, this is 2 times t. These other denominators need to match. So that means that with these fractions, I need to multiply them by 2t on top and bottom. So this will be plus, and then 2t, I'm multiplying it on top and bottom to my second fraction, which is just 4 over 1. And then minus my 5t minus 8 over 2t can stay the same because it already has that LCD for the denominator. All right, so this first fraction, when I'm multiplying, 2 times 3 is going to give me 6. T times t is t squared. 2t times 1 is 2t. Plus 2t times 4 is going to give me 8t. And then 2t times 1 is 2t. And again, this is just going to stay. So minus 5t minus 8 over 2t. So now I have 3 separate fractions, and now I'm going to combine them into a single fraction using the same denominator, but I'm going to combine their numerators. So I'm adding and subtracting, which means I'm looking for like terms, which look the same. So 6t squared, that's my largest exponent, so I'm going to start off with that term. 6t squared is any other term in the numerator to the second power, and it's not, so I'm just going to write 6t squared. Next, I'm going to move on to 8t, what looks to be the same as 8t, and that's this 5t, and I'm subtracting. So what's 8t minus 5t? Well, 8 minus 5 is going to give me positive, so plus 3t. And then I still have one more term, and that's negative 8. But it's negative minus, I'm subtracting negative 8. So I'm subtracting negative 8 minus negative 8 minus negative. That's a double negative, which means I actually have plus 8 right here. Then double check for your numerator. Can it factor? So is it in order? Yes, it is. Is there a GCF? No, there's not. How many terms are there? There are 3 terms. So I'm going to be looking for 2 numbers. I'm going to do my ABCs. I'm going to look for 2 numbers that multiply to 48 and combine to 3. And you can try to find those numbers, but you're going to find that they do not. That does not work. So because the numerator cannot factor any farther, it means that this fraction is as simplified as possible. All right, so there are a couple of examples working with rational expressions that have monomial denominators.